So, good morning. Again, our class today will be a continuation regarding the OOP principles that we have discussed previously in our last lesson. So, today, again, we will be going back with the object-oriented programming principle we call encapsulation. When we say encapsulation, we are talking about how our program is able to hide information that is not necessary for the end user for us to display. This is in order for us to provide our users a more robust and secure software. We don't want our users being able to look at our passwords even if they don't need it, right? So, encapsulation provides an ease of use for the user as well as hiding the unimportant information that our users really won't be bothering of knowing. So, we have already discussed what encapsulation is in our previous lessons since last week. We learned how we created the class, how to make use of the keyword this, how to make use of the functions coming from the other classes, as well as um, some semblance of inheritance through the use of the keyword extends. Now, we will be going back to encapsulation in order for us to discuss uh, some other techniques in which we are going to be using in order to encapsulate the data more. So for this example, yesterday we have created a hero and a game unit class. Two classes in which hero class inherits from the game unit class. As you can see, it directly inherits everything from the game unit class. The levels, the base armor, the minimum and the maximum damage per turn. Every variable from the game unit class is directly inherited. But some of this information shouldn't be readily accessible, especially if um, we are dealing with sensitive information. For example, here in our main activity.java, users should not be able to directly manipulate these variables in the main activity Java. After all, main activity only is supposed to display information, right? Only supposed to display the screen, only supposed to run the program, not display every detail that should not be displayed in this panel or in this screen. So we will be implementing what we will call access modifiers. So the first step in restricting access to variables or methods is to adjust the access modifiers. These were introduced in previous modules. Some of you already asked me, "Sir, what is the role of this word public?" You even mentioned that we have used previously the keyword private. And now in uh, void on create method, we even use the keyword protected. So they are what we call access modifiers. So access modifiers, which were introduced in our previous modules, are the idea of encapsulation was mentioned but not explained in full detail. There are four access modifiers that can be applied to methods and variables in Java, in which each of these access modifiers modify how data can be accessible through other parts in our software or in our program ecosystem. So let's start with public. As you can see here, public. means that it is accessible to the class. When we say public, it is accessible to class, package, subclass, and world. Meaning, any other programs included in this project can access this. So let's say you have created a class somewhere around this whole project here inside app. It means if the entity is public, whether wherever where in the project the other accessing class would be, it will be able to still get information from this class. So again, public class. This means that it is accessible to other classes, accessible to package. Package will be discussed in detail later, but package, this is the package. If we are going to the topmost of our project, you will notice there is a package, right? Package encompasses the whole program. So it means it encompasses the whole program here. Then subclass. So it means that other classes will be able to access this. When we say here the class, it means that the whole file will be able to access the data. When we say class, it means the whole file. Package, it is the whole project. So if we go here in the project project tab here in the left side, if we go here, we'll notice there is a folder with the mcm.edu.ph that turn-based game. This is a package. So everything within this package means it is included in the public. Then the subclass. So when we say subclass, it doesn't matter if the other class accessing this one would be inside. It could be from the other folders here. It would still be accessible. And the world. So world here in this context means this is the whole app folder. So public pretty much opens the whole file for other classes to access to. It could be usable even if they are not related project, as long as they are in the same project folder. Next is protected. When we say protected, including this protected void on create here, another example would be uh, this could also be included in the protected ones. Let's say let's change this one to protected. Let's see if this allows us. So it doesn't allow us because it throws an error. So it should be on public. So when we say protected, it is only accessible to the class itself, which is the whole file, the package in which is this folder in which the files belong, then subclasses whenever another class accesses the main activity class. So you get the pattern, right? So when we say private, let's say we set this to private. There is no error here. There will be no error because private means it is still accessible for the whole class, meaning in the whole main activity class, it is still accessible. The problem arises when, let's revert this back to no modifier state. This is the no modifier state when there is no attachment here. So the problem arises when The variable is being inherited on by other classes, or let's say a subclass. So let's go with the context of the game unit and hero. As you might have already realized, some of these variables are just borrowed from the game unit class, right? Some of these variables are being borrowed from the game unit class. After all, it is inheriting. As you can see here, this line here allows the hero class to inherit whatever game unit is. But let's say this has a label of, or an access modifier of private. Now, you will notice that this one throws an error already. So what's the error here? The error will be it is not accessible. So it's either to make the game unit public or protected. As you will notice, because protected is still here, protected is in a level in which it is accessible to its subclass. So when we type protected here, it is still allowed. But when we set it to private, it throws an error. Sir, why is it when there is no modifier, it is still accessible? I can see that subclass shouldn't inherit this, right? Subclass shouldn't inherit this because it is marked X based on our uh based on our example here. So let me show the whole screen here. Okay. When we set this to private, this will throw an error. But a no modifier still opens this up despite being it being marked as X here in the mode no modifier in our table here. What happened is because they are still sharing the same package. If you take a look back at our table, it still satisfies the package role, meaning they are still sharing, or they are somewhat still sharing a bit of a relationship in regards to the package. So the error only occurs when a file is marked as private. It is a good coding practice to actually mark every every variable as private. It is actually a good practice to mark everything as private. This is to make your program more secure and robust. Most most often, uh, hacking situations occur because um, there is no proper encapsulation of data. Data or information is not well hidden within the program. So such cracks such as this are, though they are a commonplace, they could easily be exploited. They could easily be used to create um, exploits or data manipulations easily. So how do we combat this? By putting private on every uh, variable. Now, you will realize, sir, I think I'm missing the point here. I thought you mentioned that this will cause an error. As you might already have already seen, yes, it is already causing an error, several more errors even. So how are we going to address this? We can address this by using what we call getters and setters. Getters and setters are methods in which we are passing data through methods in order to get or submit data from, while avoiding direct contact with the variables. So again, getters and setters allows us to manipulate the data without actually having direct access to this. So now we are going to practice getters and setters. So let's go back to game unit here. As you already have seen, putting this to private causes us a lot of errors. So now we will be creating what we call getters. So getters, according to our reading here, getters are used to access variables values for viewing only. Meaning, you will only be able to pull the data from the classes. So you should create a getter method for every private variable, as we have already seen here. Depending on the access level you want to give the variable, you can set the access modifier of its getter method. This is demonstrated in the example class here. So we will be creating our own getters, then setters later on. So now we will be creating getters for the game unit class. So we will create for each of these variables here. So we will start with, because we are not giving direct contact to the variables, it is safe to uh, set the access modifier here to public. So we will start with public, then copy the data type of the variable. As you can see, there's already multiple examples here, or rather suggestions here, which is actually the correct implementation here. Your Android Studio should be able to discern that, hey, this class actually needs a getter or a setter. So let's start with level. So public, why is it giving override? So again, public int, then get level. As you will notice, it will auto suggest. I didn't do anything here. So if we type this back again, public int, then there is a get level here, right? There is a get level. So let's just press tab here. So it already did the code for us, right? It already did the code for us. So again, whether this one has a this keyword or not, it is totally acceptable. Whether it has a this keyword or not. If we, again, as a refresher to us, when we use the this keyword, it means we are referring to the class-wide variables. So it is totally acceptable to not have uh, the this keyword here. So we have one for the level. Now we were going to create one for the unit name. So public string get unit name. Okay, done. We can just fold this so the code will be cleaner. Then public, again back with int, then base health, Okay, let's fold this. Public int base mana. So where is base mana here? Public int get base mana. Okay. Then public int get base armor. Then the minimum and the maximum damage. Let's just fold this here so the code will be a bit shorter. Public int. So let's min damage per turn and max damage per turn. So now that we have created what we call as the getters, we will be analyzing this later on how we are going to use this function. So again, we still have errors regarding hero. We will be addressing it later. So don't worry. Now we will be creating what we call setters. So setters has an opposite function to getters. While getters allows us to get the data that is coming from these variables, let me just make the code a bit shorter. While getters allow us to take the data from these variables, setters allows us to manipulate the data on these variables. Sir, why not directly? Again, we are trying to avoid the situation in which we are giving full access to these variables here. We are trying to avoid giving full access to prevent security flaws in our program. So now, to create a setter, we will just simply actually Android Studio makes it very simple for us to create what we call setters. So again, we will start with public. Public. Now, instead of a variable, it is currently on void method. So we will start with the similar one here. So we will start with level. So public void set level. Actually, it did is everything for us already. So public void set level int level, then this level equals level. So it actually did everything for us already. There's nothing more that we could worry about the code. So again, public void, everything is pretty much a public void method. So this one, public void unit name. So set unit name. Okay. Then next one would be uh, base health, public void set base health, then public void base mana, then public void base armor, set base armor, then public void set mean the damage per turn, and public set max DPT. So that's pretty much it. We can just clean our code a bit. Okay. Then fold this to make it a bit shorter. So now pretty much the game unit class is robust at this as it is. Now we will be setting on fixing our code in the in our hero class in which it is currently inheriting data. As you will notice, there are errors occurring in our program at the moment. So let me just hide the screen. Okay. So we will be working on with the hero class this time. So we will be fixing whatever is the errors currently having. So, because we are inserting data, we will be using the setters. Again, because we are inserting data, we will use the setters. Again, if we pull the data from the variables above, we will be using getters. If we are trying to set the data on these variables, we will be using the setters. So now we will be changing this to actually use setters instead. So how do we use a setter? Simply just call the method. So the method is set level. So let's just call the function set level. Set level. So we will start with the unit name. So the error starts with unit name. So we will be starting in order. So set unit name. Set unit name, then insert unit name here. Okay, we have addressed error number 1. So we will comment that out just for archiving purposes. Now, we will be addressing the health. So, again, set health or base health. Then insert base health here. Okay? You will notice the pattern, right? It's pretty easy when you notice the pattern. So, set base mana, then insert base mana here. Okay? Then set min dpt. Okay? Then set max dpt. Then we move on with the level. Set level. Then put here 1. So we're just copying the function. You notice that the code became shorter. Then set base armor. Then 0. Any questions with our procedures so far? Do you have any questions here at the moment regarding our lesson? We can freely remove the commented parts, ha? Can freely remove this because we don't need this anymore. Now, how do we use the getters? Let's go to main activity. So what if we are wanting to pull the information out, right? You will notice there are errors here. This is caused by our private here. So now we will be using the getters because we are trying to pull the data, right? We are trying to pull the data from uh, these variables here. So instead of directly calling unit name here, instead of directly calling unit name here, we will be instead calling the method that gets the unit name, which is this one. So instead of unit name, we will be using the getter for it. So get unit name. Okay, you get my point, right? Now, this one is asking for the base health. Again, because this is in private, we cannot directly access. So again, there is an error here. Base health has private access, meaning we cannot directly manipulate base health. So instead of actually using base health variable, we will be using the getter for it. So dot get base health. There are errors still that we are trying to fix. So it is asking for minimum damage per turn and maximum damage per turn. Again, we will be using the getters for this. So dot get min dpt, and this one dot get max dpt. So as we go down here, we are trying to eliminate as many errors as we can. So base health, it is asking for base health, so we will be using the getter for base health. Then max dpt, so we will be using the getter for max dpt, as well as this get min t. Okay. Now that we don't have errors here, let's move on. Here, we can find the base health is red because it is currently in private. So let's change that to its respective getter. Okay. So you will notice we are trying to input um we're trying to put data, right? So you cannot use get base health here because it is illegal. You are trying to put data, not get data. So we will be using setter here. So set base health here. We will be using set base health. So instead of equals here, we will be putting the 1,500 inside the parameters. Okay, then remove the equals. Then that's it. So here, because we are trying to insert data, as you will notice, there is an assignment operator here. We will be using setter. So we will be using set base health here. So dot set base health. Then we will be putting this uh inside this condition. So let's cut this one, then put it here, then remove the excess. Now you will notice there is still an error, right? There is still an error. Sir, it is asking for the base health. So because we are asking for the base health, we will be using getter here. Get base health. Okay, we have fixed it. Then here again, it is trying to display the base health. So you need to know the context of how the variable is being used. Again, you need to figure out the context of how the variable is being used. Are we trying to put data or are we trying to pull the data from the variable? So again, getter is being used if we are trying to pull data, and setter is being used if we are trying to put data into the variable. So in this context, we are trying to display data, meaning we are trying to pull data or information from the variable. So we will be using get base health for this. Okay? Then again here, we are trying to pull data here. So this will be a getter. Dot get base health. So As a bonus one, I will be giving a bonus point in written work for who is able to figure out whether this is a getter or a setter first. Anybody from our students here if able to figure out whether we are going to use getter or setter for this? No student going to answer? Okay, for this context, because we are trying to insert data, it is very noticeable due to the use of assignment operator. We are trying to insert data. So for this one, we are going to use setter. Set base cell. So again, we will be putting the value inside the parameter and remove the excess. So that's how getter and setters work. Any questions before I give you your first group activity for the third module? Any questions? Okay, I will just assume your silence as none, okay? So later, maybe today, I will be providing you the written quiz, which is in code form. Later, I will be uploading it uh, in Blackboard. So again, I want you to complete the code of this program. Again, you will be creating a monster class for this one. You will be creating a monster class and you will be doing every procedure that we have done so far for the hero class. So the monster class should also inherit the game unit because it will be using most of these variables here. It should inherit the game unit as well as it should also have getters and setters for it. Okay, I think that concludes our class for today.